Hey guys, welcome to my channel. I'm LeetCoder. If you guys are new here, I pretty much do LeetCode style questions and I explain things in the simplest way possible. So today we have a pretty interesting problem that I'm very excited about. So let's go ahead and read the problem statement, all right? You see how excited I am because I liked it. So yeah. So it says given an array of nums, right, of n integers and an integer target. Find 3 integers and nums, right, such that the sum is closest to target. I'm saying return the sum of the 3 integers. You may assume that each input will have exactly one solution, all right? So that's a very good thing they told us, all right? So we guarantee that at least one solution. So this example that we're given, right? We're giving the target 1, right? And then, pretty much they're telling us, guys, is to find a a triplet, right? When you add the sum, right, their sum, right, is as close as close to the target as possible. I'm saying, so we just return the closest one, right? We try every one of them, and then we just return the closest one that we find, guys. I'm saying, then we return the sum. So we end up returning this triplet because their sum is 2, right? And that's as close as we can get to 2. You know what I'm saying? As the closest one, guys. I'm saying it's not this one, right? 3 minus 4, right, gives you -1. The distance is 2, right? 2, this positive 2 is only distance away from it is only 1, right? So that's why we end up returning that. I'm saying, so this problem is very similar, guys, to a problem that we solved. It's called the 3-sum problem. So I highly suggest you guys go check that one out because it's gonna equip you with the tools, guys, to solve this question, guys. I went through a lot of details. I'm saying I explained a lot. I received a lot of great feedback. So I highly suggest you guys go check it out. It's gonna be very good for you guys. I'm saying you guys will be able to solve this problem pretty easily if you guys go check it out. So pretty much, guys, the way we're gonna solve it, guys, I'm saying it's gonna be the same way. We could have went the easy way out. We took the n cube, right? Pretty much try and find every combination of triplet. I'm saying that could have been, I'm saying, easy. I'm saying, but we could do a little bit better. So we, just like we did for 3-sum, we're going to be applying the 2-pointer technique, guys, to help us to efficiently reduce the time complexity. I'm saying by 1 degree. So that's kind of good. So instead of n cube, now we're going to n squared. I'm saying, which is good. So now it's going to cost us a little bit, right? I'm saying, so the cost that we're gonna have to sort it, right? Sort it, like I was saying, guys, sorting is gonna cost us a little bit. I'm saying n log n, so that's not gonna really hurt us, because that's the best we could do is n squared. So we can afford to sort just like we did for the other problem, guys. So it's gonna be the same way. So pretty much what I'm gonna do, guys, like I said, we sort it, and then now every iteration, right, we're gonna have a left and a right pointer, right? So the left is gonna start at I plus 1 of wherever spot I'm at, right? And then we start from I plus 1, and then now we get the right pointer, right, is gonna start from at the end, right? Whichever numbers at the end after we sort it, right? I'm saying obviously -4 is not gonna be at the end after we sort it, but I'm just just clarification. So we just sort the array, and then the right is gonna be at the end, right? And then we apply the 2-pointer technique, right? And then we check every iteration, we check the sum. Is that a closer one than the previous one? So that's the whole algorithm, guys. What I'm saying. So hopefully you guys were able to understand this. So let's go ahead with the implementation right now. Okay. Pretty much first, guys, we know that we need to sort the array, right? Because we're gonna be applying the 2-pointer technique. So that's how we're gonna have to do it, guys. I'm saying, to help us to efficiently solve this. What I'm saying. And after we do that, guys, what I'm saying, we also gonna have the store the result, right? So res, right, initially is going to be so we initially started off with those numbers, right? So nums of 1, right, plus the last number, pretty much, right, nums of length minus 1. I'm saying, so after we do that, guys, I'm saying we're going to be in pretty good shape. So we still add I is equal to 0. I is less than the nums that line, because we're going to be looping through the whole array, right? I plus, right? So now the next thing that we're going to do, I'm saying, is we're going to have to keep track of a sum, right? I'm saying, so now we do int sum is equal to 0, right? Then we do int the left pointer, right? It's gonna, I told you guys, it's gonna start up I plus 1 of it, I'm saying, of whatever iteration that we're at, right? I'm saying, so initially, let's say, you know, I, right? So the first pointer, right, is right there, right? The left pointer is gonna, so we're gonna be searching the remainder of the array, you know what I'm saying? So now that's why we do the left pointer is gonna go to I plus 1, right? And then the right pointer is gonna go to the last element. So now we could easily apply the 2-pointer technique, you know what I'm saying? So like I said, guys, you know, please go check out the other problem. I'm saying I went through a lot of detail. So now we the right pointer is going to be at the end, right? I'm saying, so now we could start applying our 2-pointer technique, guys. I'm saying, so we do while the left is less than the right, right? Essentially we're just going to check, right, if the sum, right? So pretty much we have to make sure that we get the sum, right? So we do sum, right? It's going to be nums of I, right? The current where we're at, plus nums of right, none of left. This one has to be in there, right? That's what makes sense. All right. So after we do that, right, we check. Gotta also make sure, guys, to do nums of right. I'm saying, so we consider all those numbers, right? So now we check, does the sum, is it greater than the target, right? So if the sum is greater than the target, guys, you know, what does that tell us, guys? I'm saying that tells us that that we need to get a smaller sum, right? So pretty much how we're gonna simulate that, we have to pretty much use a number that's smaller, right? So the right is pointing at the largest number. I remember I told you guys the array is sorted, right? So now, so if it's greater than the target, then we go to the second largest number, I'm saying. So we go to the second largest number, I'm saying. So how we simulate that, we need to decrement the right pointer, right? Then now, guys, we're in pretty good shape. So sum is greater than target, and then now let's say sum is smaller than target, right? So we increment the left pointer because we want a bigger number. I'm saying same algorithm, guys. I'm saying, and after we do that, guys, I'm saying we simply do a check, guys. So we compare the sum. I'm saying ABS of so we do res. So we get the distance, right, between that number. So we do res minus target, right? Is it bigger than this one, right? The difference, right? The distance between them, what I'm saying. So we do so we do sum minus target, what I'm saying. So this current sum that I have minus target, if it's smaller, right? So we update that that res variable, right? That's gonna have the sum, right, of the closest one. So we update that to equal to this one, right? And after we do that, guys, you know, we should be in pretty good shape. Actually, we just could simply return the result, what I'm saying. So pretty much the algorithm, right, we sorted, guys, you know, and then we initialize the res variable to equal to a solution, right, possible solution, and then we it says we're guaranteed at least one solution, so that's why I can do this, what I'm saying. So we loop through the array, and then we apply the 2-pointer technique to find a pair that could get us as close as the target as possible, and we keep updating as we found one that's closer than the previous closest, what I'm saying. So that's kind of the whole algorithm, guys. Let's check if we pass the small test case. Awesome, guys. Let's see if we pass all the test cases, guys. Awesome, we're able to pass all the test cases, guys. And I want to thank you guys for taking the time to watch this video. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe, because I'll be doing a lot of other videos just like this one. So I want to thank you guys for taking the time to watch this, and I'll see you guys in the next one.